excuse me, when this happens, we're still going to start this. Oh, I forgot to grab something. What's that? Oh. What's going to happen here is we still start these problems the exact same way. I want you guys to get in the habit of whenever it says find all your zeros or find the real zeros, to always start the problems the same way. If it says find all the real zeros, it means you're going to find all the answers that don't have imaginaries. If it says find all the answers, you're going to find including the imaginaries. In this case, I'm going to treat it as find all real zeros. Okay. It's giving you a fifth degree polynomial, which means how many possible zeros could you have? You'd have 5 real zeros. Okay. If it has a fifth degree polynomial, first term is positive. What are your dance moves doing? Down up. They're down up. We know that they're down up. If it's a fifth degree polynomial, how many possible changes of direction can it have? 4 of them. Okay. If it's a fifth degree polynomial, how many possible terms can be within its sequence? 6 of them. Okay. Now, in our case, we have a fifth, a fourth, no cube, no square, so we're missing 2. So we would have to have how many placeholders for synthetic with 5? We have 2 of them. So we'd start out the same thing. We look at our tails. Plus or minus 1, 3, 9, 27, and 81, all over 1, 3. We all right with that? Now, this question isn't specifically asking me to list all of my possible zeros. That was different. That was the beginning of 6-6, where you actually had to write all the fractions. Here I'm using them. Okay? It's a little bit different. I don't have to worry about crossing things out because I know 3 over 3 is 1. I know that 9 over 3 is 3, things like that. So as I go through this and I want to factor it, I want to find my first zero. If I'm a jerk, which I normally am, I'd say no calculator. Which means I'm just going to start with my synthetic division. And I always start at the beginning at 1. 3, 1, 0, 0, negative 243, and negative 81. All right? And hopefully by now you guys have recognized that synthetic division is pretty darn simple, aside from the fact of the dumb mistake that happens pretty often. Missing a sign, 3 plus 4 is 12, that kind of stuff. You do it all the time. All right. Bring down the 3, add, multiply, multiply. Not going to wind up anywhere remotely close to a negative 81. You agree? So I stop. Then I bring it back. By stopping and going back, excuse me, I start over again. 3, negative 3, negative 2, 2, 2, negative 2. And you can probably tell right about now it's not going to happen again. Right. So I cut my losses. I go again at 3. Were you guys able to start realizing when synthetic isn't going to work? Were you able to figure that out by the time you got to like 2 left? If you didn't, it's not a big deal, but if you did, great. And even if you wind up skipping a 0, let's say there was technically a 0 at negative 1 and I screwed something up and I didn't catch it. And I go along and I find another 0 at 9. It doesn't matter the order in which you find your zeros. They're going to show up eventually. Okay? It doesn't matter. It's like, remember, 3 times 5 is the same thing as 5 times 3. It doesn't matter if I take 15 and take the 5 out first, I'm still going to get 3. If I take the 3 out, I get a 5. It's still a factor. Excuse me. So I get a 9, 10, 30, 30, 90, 270. I'm sorry, I got ahead of myself. 90, 270, and 27. Hey, look at that. That worked. Wow, math. So I know that I have 3 as a 0. If 3 is a 0, get in the habit to write out right away that you have an x minus 3 as a 3. Now, x minus 3 excuse me, was factored out. I went from a fifth degree polynomial, which now drops this, what I'm sitting at, as a fourth degree polynomial. So I just restart from here. And I'd like you guys to get in the habit of doing this little trick. We knew that 3 was a 0. I'm going to double check to see if 3 has multiplicity. Remember, if 3 has multiplicity, it would change direction on the axis. Remember that? It could be x minus 3, x minus 3. It could be jump squared. So whenever you find a 0, especially with higher degree polynomials, as soon as you find one being a 0, recheck that one to see if, in fact, it has, bless you, if it has multiplicity. Okay? Because remember, synthetic division will take a second. 9, 19, what is it? Not 60, it's 57. And you can probably tell right about now it's not going to happen. It goes off the tracks pretty quick, right? So I know it has no multiplicity. So then I'm going to check it at -3. Okay? The trick here, you'll see the multiplicity more so tomorrow. I'm not dead, but you'll see it more so tomorrow. I'm just trying to, get you guys a little ahead of the curve here. 3, -9, 1, -3, 27. What is it? -81, 9, -27, and a 0. Okay. So again, have a 3, we have to have a -3, so it's an x plus 3 term. Bless you. Now I've dropped it down to a third degree polynomial. Now, when you have a third degree polynomial, you should have 4 terms in it. You okay with that? Whenever you have a third degree polynomial, always take a quick second. Sorry, 3x cubed is an x squared. And look at it. Look at your third degree polynomial when it has 4 terms and check and see, is it factorable via grouping? Yeah, this one is, isn't it? That's kind of the trick. When you see a third degree polynomial with 4 terms, take a second and just stop and just verify to see if it can be factored via grouping. Okay? If not, then you just continue with synthetic and stuff like that. If I go grouping in this method, what's my GCF here? X squared, good. Can I start this up? I don't want to get too far ahead anymore. All right. So take out the x squared. I'm left with 3x plus 1. What do I take out next? The 9. And I have a 3x plus 1. Are the two things that are in parentheses the same thing? Yeah. So I write them down. And then I'm left with x squared plus 9. My other 2 zeros were these two. So this now gives me my 4 terms. Positive 3, negative 3, negative 1/3. Is that going to give me a real answer? Yeah, it's going to give me an imaginary answer. So my real solutions here, I have 3 real solutions, plus minus 3, negative 1/3, and then for now, I'm not worrying about my imaginaries. My imaginary friends can still stay my imaginary friends. I don't have to think. I can think about them, but I can't talk about them. Yes? That's the student I'm talking right there. Or is it? It's my imaginary friends. So yeah, this is where it goes into, if I said find all possible zeros, then you would say plus or minus 3. We okay with that? Because I would subtract 9 and take the square root. That's where you get the imaginary root. That's how this is going to work. Yes, sir. Because where? Because I was at a 4th degree polynomial, I can't group 5 terms. That's the trick. Every time when we're using synthetic division, you always want to continue to use synthetic division because it's so much easier than any other method of calculation when you run out of terms. Okay. Yes, ma'am. How I know they're not there anymore? Because when I got to this point here, when I got to that point, let's see, we have, what is it, 3, 1, 27, so 3, 1, 27, and 9 was the last one? So our next one, if I did not want to group that, our next one that we would have checked would have been 9. And you can tell right away it's not going to work. I do this. And again, I know it's not going to work. So I go to the 81. Not going to happen. Not going to happen. But if I go to 1/3, because that was another possible 0. I go to 1/3, bring down to 3. What's a third of 3? 1. What's 1 plus 1? 2. And this becomes 2/3, and it's not going to happen. What if I go to -1? What's a third of 3? 1. What's negative times the positive is that. What's 1 plus -1? 0. What's a third of 0? 0. 0 plus this is this. What's a third, -1/3 times 27? -9. It still works for synthetic. I started at a cube. This is now squared. Yeah, Corn.
Also,
Correct. Yeah. And then you get that. So if that's your term, what's your GCF? 3. That goes away, and there's your 0. So you can continually use synthetic, but the suggestion sometimes as you get into it, if you know, excuse me, if you know a decent spot to stop, like when you have a third-degree polynomial with 4 terms, if you know that you can always double-check and see if you can group, because if you can group, it's just a little bit quicker. Whereas if you have a leading term coefficient that's not 1, you can continually synthetically divide as opposed to multiplying your tails to add in the middle and group that way. All right, let me show you one like that. Which one was it? I think it was 48. Yeah. If I look at this, if I look at this one, I have 2x cubed minus 5x squared minus 14x plus 8. I have a third-degree polynomial. It's got 4 terms in it. And right off the bat, as I'm looking at it, you might want to write these down. It's kind of helpful. And as I look at it right away, I know I can't group it. Okay? I know grouping is not going to be helpful here at all. So what I'm going to have to be able to do is break it down into something I can try to factor. So I look at my factors of my n, 1, 2, 4, and 8, divided by 1 and 2. Which means, in essence, I really only have to worry about plus or minus 1 as you go through. So I start at the beginning again. I start at the top and I work my way down. I start with 1. I have a 2, -5, -14, and an 8. Drop the 2 and go. 2, 3, -3, -3, and not happening. I erase. I go to -1. -2, -7, 7, -7. Oh, so close, but oh, yet so far. Rats. Huzzah. right there is about the worst case scenario. You had to do 4 of them to find it, okay? Honestly, I know that synthetic can get kind of tedious. I really do my best to try to not make it more than 3-4 times before you find your first zero and you start the time. I really do, because it just becomes painstaking. So here you know that you have a 0 at -2. I know that's a 0. Now, I've left off at -2. I know that this is now 2x squared minus 9x plus 4. I know that I can rewrite that as what times what's 8 you add together to get -9. It would be -8, -1. Everybody okay with that? Or I could continue with my factoring with synthetic and just go to the next number. I just did plus and minus 2. What's my next number? 4. If I try it with 4, I get a 0, don't I? I have a 0 then at x minus 4, which means what am I left with? 2x minus 1, which means my zeros are at -2, 4, and 1/2. So you could continue when you get to this point here, if you want, multiply them out, you're going to get 2x minus 2x squared minus 8x minus 1x plus 4. Plus or minus, sorry. And you'll still get the same result. Which way is faster? Synthetic. Synthetic division is so much faster, especially when you remember that you've already listed out your possible zeros. You start there. If you know that your possible zeros exist at specific values, you just keep checking the values as you go down the list. You don't have to factor it the long way. There's no reason to. It's a nice little shortcut. Does that help on this one? Because I know people are having a little bit of fuzziness with that earlier today. It's the first hour. Yes, ma'am. It's so heavy to lift up there. Is that good enough?
So it doesn't matter
Yes, ma'am. This is like you guys remember the Choose Your Own Adventure books? It's totally up to you. All right, there's many different ways to get to the zeros. Sometimes one problem's a bit quicker to go one way versus another. Sometimes if you stick with one method, it's fine. It honestly doesn't matter. You will find out doing some of the next day or two. There are tricks, and you'll get to them. And I'm trying to show you little tips here. What time is it? How's the day? Sure. You wouldn't have to do those. You just put that on a signal or use your pen. Remember, by doing it that way, if you write that as x minus 8, x minus 1, if you FOIL that out, what's your first term? It's not 2, is it? Yes, sir. Yes. You could get no real solutions on something like this because if you build let's say you build a polynomial, let's say you build a 4th-degree polynomial and you did something like this, x squared plus 9 and x squared plus 1. Those two would have imaginary zeros the whole time. If you FOIL that out, you get x to the 4th plus 10x squared plus 9, which means I would have plus or minus 1, 3, and 9 as my zeros. So if I did this synthetically, if I didn't know that, I would start at, 1, 0, 0, and a 9. If I go through all of these, you will not have any real zeros, which means there had to be a different way to look at it. Which means in your mind, if you saw this, remember the trick, 4, 2, constant? What times what's 9? You had to get 10. Then you'd break it apart and realize that synthetic wasn't your best friend in that case. So it does happen. That does happen. Especially if it was, let's say there was like an x plus 2 tacked into that, then you have x to the 5th, and then you could have broken to only have a real 0 of -2. This stuff could happen. It's a good question. Yes, sir. Remember, what times what's 8, you add together to get -9. And then what's happening up here is we forgot that the 2 has to stay out in front. Like I said, guys, I was telling this the first hour. These next couple of sections of 6.6 and 6.7, the reason that all of this stuff works, if you really go into it, is because anytime you solve for x, there's an answer. The reason that there's an answer is because there's an x. It sounds so minuscule to go through it like that, but that's kind of what this boils into. What happens here is, you guys know how in all of your classes and stuff like that, you have all these different standards you hit. Did you ever teachers showing you that stuff? The standards. As you get into these next couple of sections in Algebra 2, with all the different standards that we have, there's maybe, I don't know, 30, 40 or so standards. These lessons between 6.6 and 6.7, they have almost half the Algebra 2 standards are in this one lesson. That's how big of a topic this technically is. It's why you solve for x. It's why you get an answer when you do math. It's because of all this. If you think of it that way. Because I know that's what you guys think all this. This is, you don't nod so fast. Seriously. Jerk. But really, the reason why this stuff all works is quite literally because when you solve for x, you get an answer. And this is how you solve for x. What I wanted you guys to work on tonight were these guys here, and it's on that same section, but these are finding all the real zeros. All right. In here, be cautious of the leading term coefficient when it's not equal to 1. You get a little trick thrown into it, just like I showed you in 48. So do these. I've done 2 of them, so your workload's cut down a little. It's the same sections. It's 6.6. It's on page something or another, and it's 47 through 50. Well, say 57 because I did 58. Was it 363? Thank you. I think the PDF file is already attached. If not, you can look at the name prior because it's all still right there. Find this one here. They're just saying find all the real zeros. You do not need to find the imaginaries. But if you want to get the habit, remember how we keep writing everything out as terms before you write your zeros. I'm a strong proponent of writing out terms because as we write out terms, we can do more dance moves and we'll be able to graph all of these things. But our next step is, yes ma'am. All of those please, yeah. And we shouldn't take care of them. They're pretty quick. Yeah, because we did it. Yeah, we did 48 too. Yeah. Oh, shoot, this one's cut off there. Don't take a picture. You won't know what those last numbers are. Yeah, if you took a picture, retake it because there was a -5 and a -5 and a -2 off the corner of the side. Give me 1 sec, okay?